Hi guys, my name is Karina Mondragon and this is my final AP Calculus project and it's going to be on lesson 3.2, which is basic differentiation rules. And for this video, we're going to be basing it on the Calculus Early Transcendental Functions 4th edition book. The first thing that we have to learn is going to be the derivative operator. So it's this sign right here, d over d of x. And then we also have this sign right here. So this, when we often see this, it means the function. And then this would be the derivative of the function because it has one little sign. And then later on in other lessons, we also learn the second derivative, which would be 2. And that's how we know what we have to find and what we're looking for. I think that this sign can compare to the radical of a square root when finding the square root because, for example, right here, once we find the square root, it comes out and it just becomes simply 2. And as we can see, that this sign disappears completely, and I think that is exactly what happens with this. When we're finding the derivative, once you go through the process and you find the derivative, then the sign goes away and it would just end up being the numbers alone. The power rule is pretty important because it is an essential part of finding the derivatives. So this rule states that for any real number, n, the product of the exponent times x with the exponent reduced by 1 is the derivative of the power of x. And here below we see how the derivative of x to any number results in this. So this is how we have to bring the exponent to the front, so as shown right here, and then we have to subtract the exponent by 1, and that would give us our power of x. An example of this can be how we have the derivative of x to the 5th. So by using this rule, it states that we should bring the exponent to the front. That's our first step, so then that would become 5x, and then our second step would be to subtract the exponent by 1. So then we do 5 minus 1. So our final answer would end up being 5x to the 4th. Another good example that can show how we use the power rule is when we have 5x to the 4th. So right here we already have a number in front, so it's not just x alone. So when we have that, our first step is always to bring the exponent to the front. So when that happens, we have to multiply. It would be 4 times the 5 that is already there, and then we have the x. And then our second step right here would be to subtract the exponent by 1. So then we would do 4 minus 1. So then when we multiply, our answer ends up being 20x cubed. Another rule we can introduce are the constant and the single x rules. So right here an example was the derivative of a constant, and then a constant means just any number, so it can be 7 or any number. It would equal 0 no matter what. So for example, if we had the derivative of, let's say, 1,000, it would still be 0, and that applies to any problem that we do. And then for the single x, we have the rule that the derivative of any x would always end up being 1, because there's an invisible 1 right here, and then it would come to the front. So like another example of this can be if it was, let's say, 7x. So we're finding the derivative of 7x. Then we see that there's the invisible 1, so then we have to bring it to the front, and that would be 7 times 1, and then x, and then we have to subtract the 1. So then it would be x to the 0. And then the rule for this is that anything to the 0 would equal 1. So then it would be just 7 times 1, and the derivative would be 7. This rule is a little more simple, which is the natural exponential function, and it just simply says that the derivative of e to the x in any problem is always going to stay the same, and it would just remain as e to the x. These are a little different because we're finding the derivatives of sine and cosine, which are trigonometric functions, but I think they're still pretty simple to remember as long as you study them. So first you have to find the derivative of sine, which is just cosine, and then the derivative of cosine is negative sine. So it's like they're connected to one another, so you can see how they're related. Another way that we can study this and learn this is by just using a simple circle, so as we can see the derivatives go in circles. So we can see that the derivative of sine is cosine, and then the derivative of cosine would be negative sine, and so on. Negative sine, negative cosine, and of negative cosine it would be sine. So it would just go in a circle, and I think that this is a simpler way that we can remember this. So when we have more complex problems, it would be easier for us to know the derivatives. As we learn more and more rules, we move on to the ones that are a little more complex, but not really. So this is the constant multiple rule, and it states that when f is a differentiable function and c is a real number, then cf is also differentiable. So here down below, we see how the derivative of a constant times a function equals a constant times the derivative of the function. So a good example that can demonstrate the constant multiple rule is when we have the derivative of 5x squared. So here we see how it tells us that we can move the constant to the front of the function. So here this is a constant, which is the number, and we can move this to the front of the function. So then this could give us 5 d over d of x squared. And now we have to find the derivative of this. And to do that, we use the power rule, which is when we move the the exponent to the front, which would be 2x. And then we do our second step, which is subtract the exponent by 1. So now that we subtracted the 1 from our exponent, we have 2x 1. So this doesn't really matter since it's a 1, so we can just take that off. But we can't forget about what we did over here. So we have to keep our 5 and then d over d of x, and now we have our 2x. So what we do is that we can multiply this constant times the number that we moved to the front. So then our answer would end up being 10x, and that would be our derivative. And now for the last rule I will be introducing, it is the sum and difference rule. So this rule states that the sum of two differentiable functions f and g is itself differentiable. So the derivative of f plus g is the sum of the derivative of f and g. Down below we also see right here how the derivative of f of x plus the function g of x is going to equal the derivative of f of x plus the derivative of g of x. So an example right here, we can see how we're given the derivative of x cubed plus x to the 7th power. So what we can do, as shown right here, is that we can separate the two functions. So we can do two different ones. We can do the derivative of x cubed plus the derivative of x to the 7th. Breaking the function into two pieces is also very useful when you have more complex derivatives. So now after we broke it up, what we have to do is the power rule. So as we know, the first step is to bring the exponent to the front. So then that would become 3x. And we know that our second step is to subtract the exponent by 1. And now we're going to do the same thing with the other side. So we're going to bring the 7 to the front. So it would be 7x. And now we have to do the subtraction of the exponent minus 1. And now once we simplify that, it's going to give us 3x squared plus 7x to the 6th power. And that would be our derivative. So now the last example I'm going to show for the sum and difference rule would be this one right here, which is the derivative of x plus the square root of x. So this is a little more complicated because it has the square root, but if we break it down, it's pretty simple. So the first thing we have to do for the sum and difference rule would be separating it into two different terms. So we have the derivative of x and then the derivative of the square root of x. So how we saw in the previous power rule, we have to do x to the 1. So what we have to do would be bring the 1 forward, and then that becomes 1x, and the second step was to subtract 1 from the exponent. So we have 1x to the 0, And as I mentioned, x to the 0 would always end up being 1. So then that would just leave you with 1 times 1, which would equal 1. So this is the first half of your derivative. So we can put that right here. So that we can put that right here, 1. Plus, and then we have to solve our second part. So for our second part, we have the square root of x. So we have to know that x has the invisible 1. And then the square root is always 2. So this is an old trick that I learned, was top in, bottom out. So when we rewrite it, we can rewrite it as d over d of x, and then we can do x. So now for the exponent, we can use the trick. So this is going to be a fraction, and then the top number, the number on top that's going to be right here, is going to be the number inside, which is 1. And the number on the bottom is going to be the number that's outside, which is 2. So then it would be x to the 1/2. So that's the way of rewriting it. And now we can do the power rule once we have it in this form. So when we do the power rule, we could do 1/2 x, and then we have 1/2, and we have to subtract 1. But we can't really do much with this until we find the least common denominator. So we have to, since this one is 2, we have to multiply the bottom by 2, and whatever we do to the bottom, we have to do to the top, and the same thing if it was the top and the bottom. So with this, we're left with 1/2 minus 2 over 2, which would leave us with a negative 1/2. So we have 1/2 x to the negative 1/2. So this is like if it was a fraction. So then this and this, since they're on top, they're going to be together. So we can put it as 1 over x to the negative 1/2 all over 2 times 1, which is 2. So now that we have this, we can't have any negative number. So what we can do is we can move the whole term down, and that would make it positive. And the same thing, if the negative number was at the bottom, we can move it up, and that would just make it positive. So what we have here would be 1 over 2x to the positive 1/2. And since we want this as the original function, which is right here, we want it as a square root. What we can do is turn the 1/2 into the square root. So we can have 1 over 2 is the square root of x. And now this is our second part of our derivative, and we can combine it with our first part now. So now we can just rewrite it over here. 1 over 2 is the square root of x, and that would give us our complete derivative, which is the correct answer. The first problem we're going to be doing is number 7, which is found on page 136 of lesson 3.2. The question is to find the derivative of the function. This is just like the problem I was showing right before this one, which is the sum and difference rule. So we can do the same thing. What we know is that we have x, and then top in, bottom out, which would be 1/5. And now we can apply the power rule to this. So we move this to the front, and then we do the subtraction of the exponents. So we can do that right here. 1/5 x to the 1/5 minus 1. But we have to find the LCD, so then we have to multiply 5, and what we do to the bottom, we do to the top. So then we have 1/5 minus 5 over 5, which would give us negative 4 over 5. And when we write that, we would have 1/5 x to the negative 4 over 5. And we know that we can't have a negative number on top, so we can move this whole term to the bottom, and we would be left with 1 over 5 x to the 4/5. And this would end up being your answer. So now for number 13, we're going to be finding the derivative of this problem as well. So the first thing we have to do is we're going to rewrite it as seen here. So we're going to put the derivative sign. So now we have to use the power rule, which is when we bring the exponent forward and subtract the exponent. So then we're going to do 2x2 minus 1 plus 4 times 3, when we bring it forward, x to the 3 minus 1. So this is how it's going to be rewritten. So now when we simplify, we're going to have 2x1, so then this can just be invisible, plus 12x squared. And this is going to be our new derivative of the function of g of x. For these two problems, we're still going to be finding the derivative. And for problem number 17, we're going to have to use the natural exponential rule, which states that e to the x is always going to remain e to the x. But as in almost every single problem, we have to do the power rule with the first term. So we know that there's the 1 right here. So then it's going to be 6 times 1 x to the 1 minus 1, which would be x to the 0, and we know that anything to the power of 0 is going to be 1. So we know that 6 times 1 is 6, and then anything to the power of 0 is 1, so we multiply by 1, and that would simply give us 6. And that's going to be the first part of our function. And then for the second part, as the natural exponential rule states, e to the x is going to equal e to the x, and nothing's going to change. So then right here, we're simply just going to keep the second term, which is 5e to the x, and this would end up being our final derivative of the function f of x. We're going to have to do the derivative of sine and cosine. So our problem is y equals pi over 2 sine theta minus cosine theta. So our derivatives are the derivative of sine is going to equal cosine, and the derivative of cosine is going to equal negative sine. So that's just something we have to memorize. So now knowing these two things, we can solve for this. So our first term is just simply going to stay the same, pi over 2. So now the derivative of sine is cosine. So we're going to replace this with cosine. So we're going to write cosine theta. And then we're going to keep our minus sign. And then our derivative of cosine is negative sine. So we're going to put negative sine theta. And now here we know that these have to change the signs because negative times negative is positive. So now our final derivative would end up being pi over 2 cosine theta plus sine theta. And this would be our final derivative. For problem number 25, it asks us to complete the table using this equation right here. So when doing the table, there's 3 different sections. We have the section where we have to rewrite the problem. We have the section where we have to differentiate the problem. And then the last column would be the simplifying one. So using this, we're going to rewrite it. So the first thing we have to do is, so we're going to write it right here again. And then the first thing we have to do is not have any exponent as the denominator. So we have to move it up. And as I mentioned before, when that happens, if it's in the bottom and we move it up, it's going to become negative. So then we'll end up having 5 over 2 x to the negative 2. And then this is what happens as well. So if the x squared was on top and it were to move to the bottom, it would become negative. So this here is our rewritten part. Now to differentiate, we're going to use this one and just move it up here. So we're going to have 5 over 2 x to the negative 2. So when we're differentiating, we have to use a power rule. So this means that the negative 2 is going to move forward, and then we're going to subtract the 1 from the exponent. So when we're doing this, we have negative 2 over 1 times 5 over 2. And we're going to multiply the fraction straight across. So then that would give us negative 10 over 2. And when we simplify, that would equal negative 5. And then we're left with the x, negative 2 minus 1. And this would be negative 3. So we'd have negative 5x, negative 3 as the exponent. And this is going to be our differentiated part. And for the last part where we have to simplify, we're going to move this. We're going to move this up here. And it's going to be negative 5x to the negative 3. So as I mentioned before, we don't want any negative exponent. So what we can do is that we can move it down. We can move the whole term down, x to the negative 3. So then that would leave us with negative 5 over x cubed. And this would be the simplified version of the function. And this is how we have to do the table with every single thing that it's asking us for. Number 27 is another example of how we have to complete the table. And our problem is y equals 3 over 2x cubed. So the first thing we have to do is we're going to have to rewrite it. So when we do that, so we can keep our original function, which is y equals 3 over 2x cubed. And what we have to do would be we have to distribute the exponent to both numbers right here. So we're going to do y equals 3 over, so then 2 cubed would be 2 times 2 is 4, and 4 times 2 is 8. So we'd have 8, and then we have x cubed. But as I mentioned in the other problem, we don't want any exponent in our denominator. So what we have to do is we're going to have to move this up. So then we would have y equals 3 over 8 x to the negative 3. And this would end up being our correct answer, or the correct way to rewrite this problem. The next thing we have to do is we're going to have to differentiate. So we move this up here, and then we just rewrite it. So we have y equals 3 over 8 x to the negative 3. So now that we have that, we're going to do the power rule. We're going to apply the power rule. So we have our exponent, which is going to move to the front, and then we're going to subtract it by 1. So we have negative 3 over 1 times 3 over 8. So that's going to be multiply straight across, and we get negative 9 over 8. And then we can't forget about our exponent, so then we have to put it right here, x, and then negative 3 minus 1 would be negative 4. And this would be the differentiated answer. And now for the last column, we have to simplify the problem. So then we can rewrite this right here, and that would be negative 9 over 8 x to the negative 4. So now here, what we don't want is a negative number or a negative term. And here we see that this is negative, so as I mentioned before, we can combine it. So then everything, all of this would be on top, all of this, negative 9x to the 4th would be on top, and the 8 times 1 would be on the bottom. So what we can do is that we can move this term down. So we can say negative 9 over 8 and this x to the negative 4 would move down and it would become positive. And this would be the new way of simplifying the fraction. So when it asks you to do all three things, you just have to think about what the process is and how we're going to complete it, and then it makes it so much more simple to be able to solve the problem. So when we rewrite it, we can write y is the square root of x over x, but we have to get rid of the square root and we have to bring the denominator up to the numerator. So then the x can become x to the 1/2 because of the top and bottom out, and then we can also do it over x. So when we bring the x to the numerator, we have x to the 1/2 x to the negative 1. And now we can combine this by x minus 1. Then we find the alternate, so we get 1 over 2 minus 2. So that would become x to the negative 1. This would be our rewritten part of the chart. For the next part of the chart, we have to differentiate it. And then we have to
Good morning.